So this one is going to be on Lakehouse architecture. I am Sida Shen. I am from CelerData. I'm a product manager from CelerData, and I'm also from the StarRocks community. CelerData is a Lakehouse query engine that specializes in low latency, customer-facing like workloads on the Open Data Lake. And here we have a special guest today, Michelle from Databricks. It's a staff product manager from Databricks. So Michelle, say hi and probably do an introduction of you and Databricks.
Yeah, hi. I'm Michelle. I'm a product manager here at Databricks. I work on Unity Catalog, Delta Lake, and now a little bit of our Iceberg strategy. So really excited to be here, and I'm based out of San Francisco.
Yeah. And yeah, Michelle is an absolute expert in this field, in analytics, in open formats, in Lakehouse, Unity Catalog, Delta, and everything SQL related, and AI. And so if you have question, today would be the time to ask, right? So we're going to take a question at the end. We do have an hour booked. So we definitely have time to take your questions. So let's start. And, to get everybody on the same page, probably, there are folks in the audience that are not familiar with a data lakehouse, right? So what is a data lakehouse architecture, Michelle?
Yeah, well, hopefully folks are familiar, but I can give a quick overview. So a lakehouse is essentially like built on this idea of you have all these like files that are just like in an open format in cloud object storage in what the nomenclature is like a data lake. And so the data lake house is how do you get the semantics and the governance and capabilities of like a full-fledged cloud data warehouse on top of this like open storage, open file formats, open table formats, all in sort of cloud object storage that you own and control versus your data being locked in to proprietary formats and maybe more traditional cloud data warehousing technologies. So that's a little bit about the lakehouse architecture, and we can talk a lot more. There's a ton of components.
Yes, I think, open formats is great, right? Especially, for us working on the query side, the compute side of things. We do want to provide, low latency, high concurrency, those performances, but we don't want user to actually ingest their data into something that's proprietary, right? So you have 2 copies of data.
Exactly.
Just destroy your governance system, destroy data governance, and the ingestion pipeline is stupidly, expensive, right? A lot on the CPU, and it's really error prone, right? And also you have to maintain a whole other architecture that is a data warehouse or database, stateful, right? Use a lot of compute, and we don't like that, right? So what are some of the technology or the components of a lake house, that enable this kind of flexibility or cost efficiency, Michelle?
Yeah. So traditionally in a traditional data warehouse, a lot of these technologies would be coupled, right? But then in a lakehouse architecture, you're kind of modularizing the components and they're actually decoupled. So the core components is storage. So this is storage, typically cloud object storage like S3 or ADLS or GCS, the major cloud providers. And then the table format. So this is like the community and industries really can coalesce around like open table formats like Delta Lake and Iceberg and Hoodie. And so what these are is basically just like metadata that tell you things like the schema that provide things like ACID transactions on top of like raw like Parquet files that are managed in directories in this object storage. Okay, so then now you have all this stuff that's open table formats, and these are directories. But what you want to do is you need something that's like called a catalog. Hive Metastore, this is like the best known catalog. It's been around for like a decade. And it's a catalog that says, okay, now what are these like logical representations or like objects or tables that are represented by these just directories of files that are in this cloud object storage. And so that's kind of how catalogs, like initially it starts off as something like just saying, okay, hey, this path to a directory of files actually represents a table. The table has this name. Maybe it's in a hierarchical namespace. and maybe that has this schema and stuff like that for this like call for the different columns and stuff. And then how catalogs have evolved is now layering on things like governance and other aspects and security and controls and stuff like that. But this is, again, all on top of this file format. And the final like layer on top is the engine. So the compute engine that, yes, that's what StarRocks, Spark is another engine. That's what Databricks is kind of known for. And it's really taken on a huge life of its own, and many other engines that are out there that are like really exciting. And what these engines do is they work with they talk to the catalog. They say, hey, I want to work with this. Let's say table. I want to work with this table. They get like the path and stuff like that, and then actually go and access the cloud object storage directly and pull the right files to answer that query or whatever the user or business user or BI tool or whatever they were trying to do. And so those are the like three components of like the Lakehouse architecture. The parts that, so between the two of us, Sida, we kind of represent the whole stack, right? Because you work on the engine, and then I work on the catalog and the storage layer, or specifically the like open table formats. Yeah. And then I guess I should say that like one thing that's really cool is that all the components that I mentioned, they're all like open source. And so I think that one thing that's really cool is that this like totally flips the traditional paradigm of being locked in, because all of these open table formats, the catalogs, and then also the engines, they're all built on these open source technologies. So you're really able to have maximum flexibility.
That's terrific. And so at the heart of a Lakehouse architecture is the file format that's governed by the table format, right? And with the open catalog services on top, and with a bunch of different compute engines running on top of one copy of data. So we have that kind of, that data governance. So now we can go through, each one of the component and talk about it, right? So first, let's start off by talking about table formats, right? Open table format, I think, is really the heart of how the Lakehouse thing started, right? With Iceberg, with Hudi, with Delta, right? And there are a lot of discussion going around, table formats. Call it a table format war. So, what is your take on it? The table format war.
Yeah. So I guess first maybe I'll even touch on like what you're observing, which is that table formats. Basically, a number of projects several years ago, they all kind of started in parallel because they're all trying to solve similar problems, which is like trying to bring some level of like sanity and you said almost like a governed aspect to all of these Parquet files that are in object storage, and wanting to bring things like, okay, I want to have transactions or atomic commits and stuff like that, right? And then so there's several projects that started. Delta Lake is the one that we here at Databricks started, open source, and then also over at Netflix, almost in parallel around the same time, right? Also starting the like Iceberg project. And so when people refer to this idea of like a format war, what they're sort of referring to is this idea that like, okay, so these open table formats, they evolved, they're trying to solve this problem, they're all open source, but what is starting to happen is just like they're basically just like metadata files on top of Parquet files, and these like metadata were like have a little bit of like incompatibilities between them, right? And so we're starting to see this like idea of like almost like data silos starting to form, where okay, some of my data has the metadata for Delta Lake, some of my data has the metadata for say Iceberg, some of my data maybe doesn't have any metadata at all, and we're still working with like just like Parquet tables. And so then there's tools and query engines such as like StarRocks and CelerData, right, that like then need to be able to work with all these different formats, and not every tool works with every format exactly the same. The formats also don't have all exactly the same compatibility and features and stuff like that. And so then we're starting to see as this silos emerge, and the format wars, so to speak, refers to, I'll say it, the fact that basically vendors like Databricks and Azure, for example, standardizing on Delta Lake, but AWS and Snowflake, for example, Snowflake especially, really standardizing and pushing on Iceberg. I mean, all the vendors, they support the ones that I mentioned, right? They support like both formats in various ways, but the level of support is different, and that's what people mean with this like format war. When really it's like we're just sort of seeing that like silos were emerging.
Yeah,
Does that kind of
yeah,
make sense? Yeah.
yeah, that is true. That is, we don't want data silos.
No,
And
because then you're
and
getting the exact same thing you talked about earlier, which is people copying data around into
yeah.
different formats and stuff like that into different platforms, which is not what we want because that increases your
Yeah,
storage
if you
costs.
have formats that don't support each other, right? So why even the open, right? You lose all of the benefit of actually having a lake house. And also, we work on the compute side, right? And a lot of our users, they want to move their low latency customer facing like workloads to the lake house, but they're faced with this, this wall, this choice, right? The three projects they're different, but they're really, solving similar problems, right? They're bringing that data warehouse like capabilities and experience to open formats to one copy of data, right? So that's kind of choice is really, hindering the adoption of lakehouse architecture, right? And, we're PMs. When we design something, especially for like a quick start, we don't want choice, right? Every choice that user have to make is a chance of churn, right? So, this kind of FOMO is really, a fear of missing out on, the best format is really what's hindering, the adoption of the lakehouse, in my opinion, right? And also for compute engines, right? We have to support all kinds of different integrations. I mean, supporting one actually, for example, like Delta or Iceberg, is not that difficult because they behave just like a data warehouse with strong metadata, right? With indexes we can use, with all sorts of things, like a data warehouse, right? But with this war going on with so many not supporting each other, it's really not that great, right? And yeah, so talking about table formats, right? One of the biggest, story of the year regarding to, the format war, right, is Databricks' announcement of the Tabular acquisition, right? So what was the thought process behind this acquisition, and why did allegedly Databricks paid so much money for Tabular, right? So can you give your thoughts on that?
Yeah, for sure. So the I think Genesis, and like the rationale behind this is really like the whole format silos that we just talked about, they aren't good for customers. Like you said, it's overall hindering adoption of, moving to this lakehouse architecture. Also, we're seeing, we don't want to repeat the mistakes of the past. And so we're seeing, right, these like silos emerge, and we're seeing that this is causing like this choice was causing like a lot of like customer frustration. They don't want to have to care about what open
Yeah,
table
exactly.
format their data is represented in underneath. They just want to have like a lakehouse as the best price performance, right? Get the best
Yeah,
engine. They want governance. They just want to like the business intelligence, not to stress about the table format. And so really like here at Databricks, what we saw is, okay, this is really causing a lot of customer pain. And what we want to do is we want to sort of like end that and actually make it so that you don't have to choose between the different table formats anymore. And so really by, acquiring Tabular, I think we get two things. The first is that we're able to leverage a lot of the folks from Tabular, their expertise in-house in a way to like, sort of kind of bolster our own offerings around like Iceberg. So we already, for example, support like via like a feature called Uniform, exposing tables via the Iceberg REST catalog interface. And we really want to
yeah,
embrace Iceberg REST catalog because we think that like catalogs is like sort of the next frontier. We want to like, lay to rest this format choice and actually make it super, super, super easy to actually interoperate with the catalog layer. And so that's the first thing that we brought on from the Tabular
yeah,
team is just like a ton of like expertise in open source and a ton of expertise in Iceberg. And then secondly, I think one thing that we're really excited about is actually integrating parts of the Tabular catalog into Unity catalog. There's like some really interesting things that they've worked on, especially around like Iceberg REST catalog interoperability and things that like like table optimization and management and stuff like that we can incorporate. So those are the two things, but really, like, I think we're really excited because this feels like that step where Databricks is now sort of joining the Iceberg community in a really big way, in a way that we haven't before, and bringing these communities closer together.
Yeah, that is great. I mean, we love Iceberg, and but a
We
lot
do
of
too.
the yeah, we can see, and yeah, there are a lot of talk, in the especially in the Iceberg community, that this acquisition, what does this acquisition actually mean for the Iceberg community? Because a lot of the users, including the users in our StarRocks community who are using Iceberg, they're concerned, right? So which direction is Iceberg heading, and how is this acquisition? How is Databricks being a part of the Iceberg community now? Is going to impact the roadmap, and what does it look like?
Yeah, for sure. So I think you can actually, if you're involved in the Iceberg projects or Delta Lake projects, I think you can actually see a lot of this happening already, which is that our end goal is that we want to bring the formats closer together and ultimately converge the formats and their capabilities to truly eliminate this choice. That's going to be, of course, like a multi-year journey, right? And we also don't want to like hamper any of the innovation that's going on in these communities, but or hamper more broadly innovation that's going on in the industry as a whole. But one of the things that's really exciting is that we're already seeing these like low-hanging fruit opportunities to be able to bring capabilities from Delta to Iceberg and vice versa, in such a way that we're actually kind of just like smoothing out just these rough edges of incompatibilities. Because if you really look at like like what problems we're trying to solve, and the like metadata and stuff like that, is really like we're close, but those incompatibilities cause a lot of problems. So I'll give you an example, which is like Delta Lake, we have this thing called deletion vectors. Iceberg has this thing called positional deletes. They're both doing something very, very, very similar, which is just trying to make updates faster, right?
Yeah, but we as Korea will have to support both.
Yes, because they're different. They're actually not compatible. So yeah, exactly. So if you're trying to do this like metadata translation between both, they're actually incompatible. And so then now on the query engine, well, now you have to know how to read deletion vectors. You need to know how to handle positional delete files and stuff like that, right? So one of the things that we're actually doing is bridging those compatibilities in between deletion vectors and positional deletes in Iceberg v3. Something else that we're really excited about, right? So we announced adding variant data type support to Delta Lake, right? And so something we're really excited about is bringing variant type to Iceberg, and that's also going to be in Iceberg v3. And so all of these, if you're following along with the communities, you can see it's out in the open. We're already making like huge strides to bring these closer together. And I'm really excited because, we're also going to be starting to bring the communities together, and like, Databricks hosting Iceberg meetups and stuff like that, right? Because we really want to like join the community and bring them together. So having to support two different things isn't good for anyone.
Yeah, I think this is great. I mean, Databricks is definitely a strong force in the Lakehouse. I mean, yeah, you guys started it, and yeah, in the Lakehouse kind of open format field, and having you guys in the Iceberg community will be great, for its future innovations. And alongside the Tabular acquisition, just a few weeks after, the open source of Unity Catalog, which is announced. So why do you guys open source Unity Catalog, and what was the kind of the thought process behind this decision, right?
Yeah, for sure. So actually, I should say I'm wearing my Unity Catalog T-shirt right now. This is a vintage. Do you have one too? No. Oh, you should get one.
Yeah, I do.
You do have one, right? Yeah, we got you one.
Yeah, I just forgot.
You're not wearing it. It's okay. Too. But anyways, yeah. So this is the shirt that we on the team got with the day that we open sourced Unity Catalog. I think actually Matei live on stage at Data and AI Summit, made the GitHub repo public, a super viral moment. Some of the motivation behind it, I mean, I should say that we kind of actually always intended to open up Unity Catalog. That's like Databricks has a super rich history in open source, right? With like Spark, of course, MLflow, Delta Lake, and then now Unity Catalog. So we're like big believers in open source innovation and in the strength that comes from having like an open community around these technologies. The big motivating factor for why we even developed Unity Catalog internally, I should say, is that we found basically there's a lot of limitations with like the leading open catalog standard, which is Hive Metastore. And so we 4 years ago started developing Unity Catalog internally because we saw that there was like this emergence. So Databricks is a data and AI company. There's this emergence of, okay, well, it's not just tabular data that you need to think about and that you want to govern,
Yeah.
and that has all these attributes that we just talked about, where there's like metadata around the collections of files that we want to actually have governed and cataloged and managed in a unified way. And so that's where Unity Catalog was born of. Actually, each of these, the story behind the logo, by the way, is that each of these shapes represents the like different assets that you can have in Unity Catalog. So it's like
Oh, really? Wow.
squares.
Didn't know
Yes, I know,
that.
right? Actually, it says on the back of the shirt.
Oh, yeah.
But squares, it's tables. The triangles is like AI assets, like models and
Yeah.
functions, and then this part in the middle. I think the hexagon, is it a hexagon? Or is it it's a hexagon, right? Anyways, the
Yeah.
hexagon represents like unstructured data, like
Yeah.
volumes. So that's like the genesis behind Unity Catalog. And then, we have over 10,000 customers running Unity Catalog in production. We have built out a lot of those core primitives and APIs that, we feel really confident behind. And so then it felt like the right time to actually go and say, okay, now we're ready to open this up and feel like we have something that's really technically solid here that we know solved a lot of the challenges that we were facing with Hive Metastore.
Yeah, even from the logo, it's bridging structured data and unstructured data, and those SQL analytics and AI applications, right? And I see a
Yep.
lot of this, on the Databricks channels, but probably users are skeptical, right? So how exactly this bridge data and AI? So can you give a more of like example or a deeper dive into how exactly Unity Catalog can do this?
Yeah. So actually, maybe I have some slides here that I can talk through. This is probably a good time to talk through some things. Yeah, I have some
Yeah.
slides here that just give an overview of Unity Catalog, and it's just some of like the core principles. And then I have an architecture slide on the next diagram. But first, I'll just give a quick overview. So I think there's 3 sort of core principles behind Unity Catalog. It's a lot of what I've said, but basically embracing multi-format support, right? So the only open catalog out there that supports like any table format, including Delta, Iceberg, Parquet, CSV, JSON. And then also we thought it was really important that it's like a multimodal catalog. So here with multimodal, I mean, it's like a universal catalog for your tabular assets, your unstructured data, like PDFs and images and stuff like that, or audio files and stuff like that, and then AI assets. So you're able to govern and manage all of these things together. And then finally, the essential piece behind Unity Catalog is that it's unified. So you get this like unified view to like discover, govern, do auditing and lineage across your entire data estate. And so a little bit of what this looks like under the hood, although I should say this is like obviously not an actual like services architecture diagram, but a little bit about what the structure looks like is that you have Unity Catalog here. It's exposing these open interfaces, so the Unity REST APIs, the Iceberg REST Catalog APIs as well. In the future, we intend to add Delta sharing as well to the open source Unity Catalog server. But then also, all of these are providing unified governance across all of your different data and AI assets. So these are actually, what the abstractions are called, and the resources are called in Unity Catalog. You have managed tables, external tables. These can be in any format, right, like Iceberg or Delta, as I said. Volumes, which is the abstraction that we use to encapsulate, say, like images, audio, PDF files, and stuff like that, and then
Yeah,
also
that is
functions
really,
and
yeah, that is really
models.
useful for unstructured data.
Super useful. I
Yeah,
have so
yeah,
and
exactly.
I mean I'm super excited about seeing more integrations too, like around like volumes, because this is something that I know that our users love on the platform, is being able to access these things together, right? Because so here I'll give you an example. So
Yeah,
say you're using any of these tools that are here in this like any engine up top, this layer up top, right? You have like all these different cloud platforms and tools. You have like these different ML tools, right, like MLflow or LangChain, and then you have like different compute engines. And so what you might have is you might have like this piece of code, right, that needs to access tabular data. It also needs to go maybe pull some like PDFs or images and stuff like that for training data. And then also maybe you might be like executing a model. And so this is actually like the same user who's needing to do all of these things. And when these are governed or managed in silos, that's when you have things like like maybe duplicate access policies or other things that can like cause like frustration to users when these things are operating in silos, because you're not getting also an end-to-end picture of like lineage. Like I used this version of this data set when I was training this version of this model or something like that. So
yeah, yeah,
really excited to
exactly. I
like bring
think,
all of these together. Yeah.
yeah, yeah, I think this could be, like really big, the ability to both pull from structured data and unstructured data, right? And I think even for large language models too, right? People use RAG, to enhance, to basically give it a longer context window, right? And those applications are not only, vectors, right? They probably, they need structured and unstructured data together, right? Multimodal search. And this can be very important, in those kind of applications as well, I think, right? What do you think?
Yes. Oh, absolutely. I'm so glad you mentioned that, because I think that's actually something that we're really excited about. Is so in the 0.1 release of Unity Catalog, right, we had functions, which can be like SQL or Python functions, which can be
Yeah,
leveraged. Actually, you can use Unity Catalog almost as like an AI tool registry or catalog that we actually have already. These are already out there, like integrations with LangChain, for example. So if you're building like a
that's
RAG
true.
application with LangChain, you can actually go and like leverage functions from Unity Catalog, where you've like registered those functions, the bit of code, some metadata description around it, and stuff like that. It's in this nice, right, like 3-level namespace and stuff like that. So you can just reference the function by name.
Yeah,
Like I don't know, some numbers or whatever the name is. Summing numbers isn't the best function example, but it's like all of this with these like really nice abstractions and APIs, you're able to create really powerful applications.
yeah, yeah, that is true. And we talked about AI, right? How Unity Catalog, or how Unity Catalog, the open source, can help bridge this gap, right? And I also saw interoperability there. So how, on the first slide, so how can this Unity Catalog open source help with, the table format world and all of the pain that a table format was causing for the users, for our users?
Yeah, no, for sure. So here I'll refer to this arc diagram again, but I think one of the things that we're excited about with the catalog is that, like I said, there's not that much differences between the formats. Right now, there are still, well, ultimately our end goal, right, is to converge them to completely
Yeah,
smooth out those differences, but they're going to remain for a while. And there's just this little bit of like metadata translation and stuff like that that needs to happen. And so something that we're really excited about with the catalog, so the catalog plays like an important role in Iceberg. It's increasingly playing a super important role for Delta tables as well, right? As like a commit coordinator for like multi-table commits, for managing things like,
right.
say even like, branches or whatever of your data sets. And then also, I think also just like it's the source of truth for
That's
like
true.
writes and commits, and like what's the latest schema, what's the latest table version, what's the metadata file that I should be looking at if I'm an engine, right? If I'm like, if the engine needs to go talk to the catalog. And
Yeah,
so one of the things that like, so the role that Unity Catalog can play, and is playing for eliminating those differences is just saying, okay, this is the idea behind an API, right? It's an abstraction on top of all that complexity that's underneath. And so Unity Catalog exposes both the Unity REST APIs, right, which gives you access to all these different tabular assets, and then also the Iceberg REST Catalog API, which gives you access to tabular assets. And as an engine, maybe you don't even need to know anymore, like what's the like underlying format or whatever. Unity
That'll
Catalog
be a
can
dream come
actually
true.
just like, if you're accessing, you can access any table through the Iceberg REST Catalog interface, right? It's an API, and then what we can do is almost like abstract away all that complexity around the different metadata and compatibilities, make
Yeah.
them look like each other, right? And then expose that to the engine. And so that's the role that we see Unity Catalog playing, is basically being this like amazing like interoperability layer uh, between all of these different formats.
Yeah, that is terrific, and that is at least from a query engine or compute engine perspective, this is going to make us and our lives so much easier,
Yeah,
and the
you
users as
shouldn't have
well,
to know,
right?
right? Yeah.
Yeah, we shouldn't have to know, and there is only one integration that we need to build, right? And then that's going to enhance, for us to push the boundary even further, right? Because there's less work, less manual work we need to do, right? And we talked about open formats and even catalogs, right? Open catalog services. And my next real question would be, there are more vendors on this space, right? For example, Snowflake, that are adopting a very similar approach, right? They're embracing open formats, open table, open file formats, even the open catalog service, right? Basically like a lakehouse architecture, right? So what is your perspective on this trend? And
Yeah.
everybody's moving this direction. And
Yeah.
what it's mean
Well,
for users.
I guess I should first say it's great. It's great for users, right? And it's great for us, because this is like, so Databricks, I think we actually were like the category creator for the Lakehouse category, and I think to us it's like amazing to see vendors such as Snowflake, which where traditionally, and 99% of their data is still in this like proprietary format and stuff like that. They're that more of the like data warehouse that I was describing before, right, in the cloud. But now we're really excited to see them and other vendors like really embracing the Lakehouse architecture, because I think that that's just validation that, like, at the end of the day, this is what customers want. They
Yeah,
want this like
yeah,
open, decoupled stack. They want to be able to bring the best tool for the job, right, to a single copy of data, but also be able to get that unified governance and access control. And so I think like maybe you're referring to, I think Snowflake, actually, I think they recently also open sourced a project called Apache Polaris,
yeah,
which is an Iceberg REST catalog implementation. And again, I mean, this is like nothing but good news, because Iceberg REST catalog, we embrace Iceberg REST catalog, right? Unity Catalog exposes Iceberg REST catalog interface. Many other vendors have said that they're also embracing Iceberg REST catalog interface as this like catalog interop or shared language almost for tabular data. And so yeah, really excited that Snowflake is also getting on board the train and has launched this open source project. I mean, at the end of the day, it's like it's the spec, right? It's the Iceberg REST catalog interface. It's an implementation of a spec for working with Iceberg tables, and we also implement the same spec and other folks as well.
yeah.
I guess I
And
can't help but add that it's funny because the Snowflake catalog itself doesn't implement the spec, but it can talk to at least this other open catalog, right, that does implement the spec. Yeah.
yeah. And with everybody on board, right? Almost. And do you believe the open lakehouse architecture, where it is now, the architectural wise, it's gonna has all of the necessary components, right? Do you expect any big change in the future? And which component in the lakehouse architecture is going to be the key moving forward?
Yeah. I mean, I think that like where we are, so I mentioned like the major components. The major components are all there, which is you have the open like storage table formats, you have the catalog, and then you have the engine ecosystem. I guess basically what we just talked about here. And I think like what is sort of next for this open lakehouse is we're going to see a lot more emergence around the standards for like AI and ML and these unstructured data assets. There's like so much rich ground there that like we, you know, have barely scratched the surface of. And Unity Catalog is basically one of the like the first open catalogs, I think, that like really provide this like the Unity REST APIs across all of these objects. And so I think what we're going to see is more bringing all the great things that we did for like say like table formats with like Delta, right? This like metadata around like tabular data. You're going to see things like metadata for like volumes and stuff like that. And
Yeah.
for functions like the AI tool registry, like all these basically emergent applications that we're going to see. So that's like one prediction. And then I think the other thing too is that the other prediction is that as an industry, we're also going to converge around like what I said, this like interoperability between catalogs and the shared language. So I think we're going to converge around like basically a shared language for this like open catalog standard for how we work with each other, so that we don't get. I mentioned table format silos before. What we don't want is like like we're already seeing this happen. Is like metadata silos in the catalog, and we
Yeah.
don't want that. Yeah.
Yeah. Yeah, I think I mean, in the future, right, with everything on the open format now, for us, specifically focus on the compute, right? We are a kind of like CelerData is a specialized tool from the beginning, right? But that makes it kind of difficult, right, without open formats because, that require a specific vendor specific kind of format. You have to ingest it, right? And that creates a lot of trouble, right? And now with open formats with this kind of capabilities, it's just like a data warehouse. It makes it so much easier, right? And also, I think this is great also for compute. One of the reasons is that you guys basically, working on formats and working on catalog, and basically make it frictionless for users to switch solutions, right, on the compute side, right? And this definitely sparks innovation, and because it's gonna make the competition a lot more, right? Then whether you have to ingest, right? So I think this is great for kind of new projects to emerge on the compute side, right?
Oh,
And I
absolutely.
think, yeah, absolutely. And specifically, I mean, I think this is also great for specialized tools, right? Before, I mean, you have a monolithic solution, right, with a proprietary format and a query engine on top that only works with that proprietary format. Whether it's storage compute coupled or decoupled or not, that doesn't matter, but it's one solution, right? But now you're able to have multiple computes on top of one copy of data, a single source of truth of data. And that is great for specialized tools, right? Now you can have something like Spark, for machine learning, and for those batch processing job that runs for like hours, right? ETL workloads. And you can have machine learning or machine learning applications that also run on that piece of data. And you can have that SQL query engine that specializes in interactive low latency high concurrency workloads like CelerData, right? And I think it pushed the boundary even further, in terms of what analytics is going to be capable of, right? Because we're going to have so much more specialized tools that is going to work in this architecture, right? And I think this is great, right? We talked a lot about table formats, catalog service, and even compute engines, right? And actually all of those technologies that are there that we talked about, all the theories that they actually work today, right? And we actually have a few demos that we can show, right? So Michelle, you can share your screen if you have
Oh,
anything.
you want me to go first? I think, well,
Yep.
so I'm here. We have a couple demos, right? I think you said you're going to demo some of the stuff with like query engines, right? Working with
Yeah.
tables. I have a demo. So one of the things that I'm really excited about. So we had the Unity Catalog 0.2 release. I have a demo for something that I'm really excited about that we added 0.2. By the way, if we'll throw up the links after the end of this webinar, but folks who are interested should check out the latest release notes. We like packed it chock full of things. There's a new Unity Catalog UI, added identity, authentication, authorization, like grants, privileges, and then something that we also added was the Spark integration, and then also we added models, so register models to Unity Catalog. So you can use open source Unity Catalog as a model registry as well with, say, for example, like MLflow models. So the demo that I have is, I'll show you, I'll give a quick spin just through the Unity UI and then also show working with models in MLflow. So let's see if I can get all of this working. I just prepared it earlier this morning. Okay, let's go.
Yeah, you can share a screen.
Yes, I'm working on it. Okay, cool. So I have no idea. Can people see my screen? Does this look right, Sida? Are you able to see the UI? No.
Oh, sorry, I was muted. Yes, I can see it.
Yes. Okay, great. Okay, good. I was like, okay, wait, I'm stressing. I hope no one's looking at my private messages right now. Okay. Cool. Okay, so here's a little bit of the new Unity Catalog UI. Let me see if I can make it a little bit bigger for folks to be able to see. So I set up, so this is like the default catalog. So Unity, I should say, has a 3-level namespace. So the top level is called a catalog, second level is like a schema, and then also you have the objects that are within the schema. And so here's the different objects that you can have inside this schema. So this is some of the defaults that already come out of the box if you just follow the Unity catalog quick start, right? So maybe you have some tables, you have some JSON files or some text files that are in volumes, right? And then also functions, and then also models, except I don't have any models right now. So one of the things that I'm going to demo is working with MLflow. So this is the MLflow UI, which I got set up here, working with MLflow with Unity Catalog. So I realize I'm saying a lot of concepts here. I'm going to start with saying MLflow. It's another project that we open sourced and maintain here at Databricks. There's this concept of like MLflow models. It's just a way to package up models and then be able to go and run and deploy them on things like Azure ML, on Databricks, of course, and on Kubernetes, or even run them as user-defined functions in Spark. And then one of the things that's really cool is it has this concept of like a model registry. We're able to track the like models and maybe like different versions of the models that you might have been training and stuff like that. And then Unity Catalog, we also have, so Unity Catalog can basically act as a model registry with the MLflow integration. So Unity Catalog has this concept of registered models. So you see I don't have any right now. And then also model versions. And so Unity Catalog in concert with MLflow can act as a model registry. And then I should say that like bringing all these concepts together, right, you can see how powerful it is to have all of this discoverable and governed in one place, where you have models which are probably working with data that is in volumes, data that might be in your tables. Maybe you have a bunch of like customer review text, product review text and stuff like that. And maybe you also have a bunch of like product images and stuff like that. And then you want to go and be able to do some like AI with that in your models. And then, even later, getting really fancy, be able to like execute, predictive models and stuff like that in functions. So all of this, it's all discoverable in one place. And so this is the open source UI. So what the quick demo I set up, I mean, it's really simple actually. So you can see I just have some code here, which just like basically does a small, I'm going to train a small model and then register it in Unity Catalog. So hopefully everything is still running. I'm just basically just going to run this demo script. And then if all goes well, what we'll see is that I should have a model that is now registered in Unity Catalog named Iris. Great, here it is. And so you can see also there's a, well, if I refresh this, there should be a demo run 15 seconds ago, of the model. So we just trained a small model. You click into it, you can see that there's a version here, right? So this is the first model training run. So say maybe what I do is I want to like train it again. Maybe I made some tweaks to the training data set. And then what you can also do is you'll see here, so I'm just going to train another version of the model basically. So what we should see is that now there's actually a second version of the model that's registered here. And so all of this, I should say, one thing that's really cool is this is also all with unified governance. So models are actually just like a collection of files under the hood. And just like volumes and just like tables in your data lake, all of these things are just in directories in object storage. And so Unity Catalog with like credential vending can actually govern and create unified access control for all of these concepts all together in one place. So that was a quick demo showing a few of those concepts. And yeah, you can find all of the stuff for this documentation and stuff like that on unitycatalog.io.
Yeah, that is
Okay.
beautiful. Yeah, basically showcase, data and AI can be governed together, right? With credential vending, and we can get, the appropriate authorizations and to, do all of those and have one place, with all of the credentials and access control get governed. And that's great. That's great for user, right? And, you focus a little more on the AI side, right? And here I want to show a very small demo that it's more focused on the SQL side with table formats and interoperability, right? And here we're going to use CelerData copy BYOC. So it is a managed version of commercial managed version of StarRocks, which is a Lakehouse query engine, right? It specializes in low latency, high concurrency, customer facing like workloads, right? So this is a CelerData site. You can go take a visit. Basically, you don't need a data warehouse, right? Because you can run all of the crazy workloads on your Lakehouse, on your open and standardized table and file formats, right? And so here I want to showcase Unity Catalog and CelerData, right? So very simple demo that's based on the open source version of Unity Catalog, right? CelerData Cloud BYOC has integration with all sorts of table formats and catalog services, right? So the first one I'm going to use to connect Unity Catalog open source is actually not a connector we built specifically for the open source version of Unity Catalog. This was actually built like way before Unity Catalog was open source, right? This was built for the Databricks managed version of Unity Catalog, but it also works with the open source, right? So it's actually compatible the two. So I already created the external catalog here. It's called UC, right? So this one, it's connecting to a Unity Catalog open source version that's deployed locally, right, on this machine, right? And here we can just show the databases from Unity Catalog, right? And we can see the default one, which is kind of the quick start database that comes with every single Unity Cloud open source installment, right? And then we can show tables from this UC from this database, and then we can query the data, right? So this basically showcases, the open source version of Unity Catalog actually is compatible with, its Databricks managed counterpart, right? And the second short demo I'm going to show is actually we don't use any proprietary or UC Unity Catalog specific client, right? Here we're actually going to use the Iceberg REST client of CelerData Cloud BYOC and see if we can still, connect to the same, to the same data that's stored and managed, governed by Unity Catalog, right? And here I already created this catalog, external catalog, right? And we can set the catalog to this UC REST, and we can still read the data. But how, right? And this is actually through Unity Catalog's uniform, right? So we're actually reading the data from Unity Catalog as it was Iceberg data, right? And this showcase, the capability, like the interoperability that you can experience today, with a Lakehouse architecture, right? And this integration is available at the Unity Catalog GitHub site. Just right here, you go to docs and integrations, and you can see CelerData here, right? And you can try it for yourself. And you can sign up CelerData Cloud BYOC and get a 30-day free trial and try all of that today. Okay, and that's all for my demo. Turn off screen share. And now let's take a look at some question. We do have some question in the comment. So the first question, when will the Databricks-hosted Unity Catalog, not the open source version, be more open to open source distributed SQL engine, whether it's TrinoDB or StarRocks. You want to take that, Michelle?
Yeah, for sure. I guess I should say, Sida, I'm pretty sure the demos that you just did were against Databricks
Yes.
Unity
No,
Catalog,
that was the open
right?
source one. That
Oh,
was
this
the
is
open
against the
source
open
one.
source.
Yeah.
But I know that you also have a demo for against Databricks
Yes.
Unity
Yes.
Catalog, right? Yeah. So I guess, Declan, to answer your question, both all Unity catalogs have the same Unity REST API standard,
Yes.
expose the same APIs. And so you can point an engine that has a Unity catalog integration against any Unity catalog instance, whether it is Databricks or open source Unity catalog.
Yeah.
So
Yeah, like it's
there's,
just
I think, some guides and blogs for how to do this online, but basically it's as simple as just changing the URL to be your like Databricks workspace URL instead of, you know, your self-hosted Unity catalog.
Yeah, like the one I just showed before, right? And that was a open source version of the Unity catalog, but the connector I used was, you know, built well before before the open source, right? So, you know, it all depends on the query engine, whether they, you know, implement. And for CelerData, it's using the Unity catalog SDK, right? And that was a really smooth process, right, to support this. And there's a second open source Unity catalog is open and can be leveraged for Iceberg. And okay,
I think this is
that's
just
not
a
a
part
question.
two of
Yeah,
the same
yeah,
question. Yeah.
yeah, that's true.
Yeah. I mean, that's the whole goal actually is that, you know, all of these things are open, and yeah, Unity catalog and like all Unity catalog is Unity catalog. And they both implement the same APIs.
Yes, and we do have more in the QA. So the first question, UC open source was announced about a week after the Polaris announcement. Was the decision to offer UC as open source influenced by that, or did it happen to announce at the same time? Right? Is there a shift in opinion for Snowflake and Databricks on OSS in this space? Is there a shared opinion?
Yeah. It's funny that you say that because I think Snowflake actually announced that they were going to open source a Iceberg REST catalog implementation in 90 days, but they didn't actually have any code. And then you're right that a week later at our Data and AI Summit, we open source Unity catalog 0.1 with code, making the GitHub repo live on stage. And as amazing as the engineers are at Databricks, as amazing as they cannot create an entire catalog open source project in less than a week. And so I guess to answer your question, no, we have been working on this for quite a while. Unity catalog, and I would almost say that the announcement maybe goes the other way.
Yeah. So, you know, it's good, you know. So there is, you know, everybody is on the open train. So, and that's good. That's good for the user, right? And the second question I have in the Q&A session is catalog and table the same thing?
A great question. Well, so I think I mentioned this, and I even have slides if you want to pull it up, just like a little bit of Unity Catalog 101. Catalog is just it's the top level of the here I have a little bit of a feature overview, the resource hierarchy. So it's a three level namespace modeled after data warehouses. So you have catalogs and then schema, and then these are the different objects like tables, volumes, functions, and registered model. So this is how they're related. This should directly answer your question.
Yeah. So, you know, table is everything below table and catalog is everything above the table, right? So table and file format are, you know, the table itself, the table format, and everything else, the governance, you know, where the tables are stored, right? And, you know, where the metadata point to, you know, those are on the catalog level, right? So they're very different things. And the next question, those are the submitted questions. Somebody said hi in the Q&A. I'll make it public. And can we expect similar performance on metrics in Lakehouse architecture with StarRocks as similar as proprietary storage engine architecture. So yeah, I think that's a question for me. So we actually do have a benchmark that runs against StarRocks storage and compute coupled architecture. That's the fastest possible, right, on our proprietary format versus on a Parquet file. And on TBCD as 1 terabyte, and the difference like 10%. So it's really not that significant of a performance trade-off for the benefits of actually managing all of your data in one place, right? All the governance benefit, flexibility, hosting multiple computes on one piece of data, right? So I think, no, the performance is not exactly the same, but it's definitely worth doing, right? Going on Lakehouse. Second question, does StarRocks support all existing features when we use Lakehouse remote storage, like full text index and queries? I would say no, but with a catch. So you can use a materialized view to basically convert whatever table you have, whether it's Iceberg or Delta, right? Convert that into StarRocks proprietary format, and then do acceleration, right? And that materialized view is like fully managed, so it's going to sync with the data by itself. So you still have the single source of truth on your lake, right? And then you can use all sorts of things like indexings and StarRocks indexes and StarRocks ways of partitioning and those things to accelerate your query performance, right? And next question. What kind of questions should I ask myself when designing the engine to use with the Unity catalog? Like, why should I use Spark or StarRocks or any other engine? I think I'll start first. So, the good thing about Lakehouse is it's when you switch a solution on the compute side, you don't move the data, right? So basically, essentially making every compute engine stateless, if that's no, it's not 100% stateless, but you don't have to migrate your data, right? So what I would say is try out the solutions, because let's say switching from Trino to StarRocks, right? It's just a start up StarRocks and then point the catalog, and to where the metadata is. And then you can just start querying in like 10 minutes, right? So try out all of the query engines that are out there, and then decide, which one that best suits your use case. And then better, you can host multiple compute engines on that one copy of data. So sometimes you don't have to choose, you have multiple, right? You can have Spark for your long running, like batch like workloads, and you can have StarRocks that runs, low latency, high concurrency, customer facing like workloads all at the same time on top of one Unity catalog and one copy of data, right? I'll make this public. Can we query the Unity catalog metadata used in Databricks from anywhere outside of Databricks, like my local computer?
The short answer to that is yes, absolutely. So you can get your own like local Spark and point that to Spark session and point that to a Databricks workspace URL to use Unity catalog there. Yeah.
Okay, I think I think that was the last question we can take, and this is the time, and we're at the time. So if you have any further questions that are not answered, we'll get back to you, after the live event. And if you have further questions, please post them in the StarRocks or Unity Catalog Slack channel, and be sure to join the StarRocks Slack channel right there. And also, you can find all things Unity Catalog at unitycatalog.io. And thank you everybody for joining this webinar fireside chat. And thank you, Michelle, for giving us this talk.
Yeah, absolutely.
That was a lot of fun. That was a lot of fun. I definitely learned a lot.
Yeah, thanks for having me. All right, have a great day.
Thank you. Bye. Thank you.
Talk later.